What if the sun started dying? Not in 5 billion years the way astronomers predict, not gradually, not theoretically, but now, this decade within our lifetime. That is the premise of Project Hail Mary, the most scientifically ambitious blockbuster in years. And I am here to tell you, a lot of it is not as far-fetched as it sounds. This video is two things at once. It is a review of one of the best science fiction films of 2026, and it is a breakdown of the real science hiding inside it, because there is more than you think. Mild spoilers ahead. You have been warned. Project Hail Mary is based on the best-selling novel by Andy Weir, the same author who wrote The Martian. Ryan Gosling plays Ryland Grace, a middle school science teacher who wakes up alone on a spacecraft with no memory of who he is or why he is there. His memory returns in fragments. What he gradually remembers is that he was sent on a one-way mission 12 light years from Earth to solve an extinction-level crisis. The sun is dimming. A microscopic organism called Astrophage has colonized the surface of the sun, consuming its energy and reproducing at an exponential rate. If nothing stops it, Earth freezes within 30 years. Grace is the last hope. And then he discovers he is not alone. The film runs 2 hours and 36 minutes. It earned 94% on Rotten Tomatoes. It has grossed $148 million in its first week, and audiences gave it an A on CinemaScore. The numbers say this movie works, so does the science. Let us find out. The science of Astrophage. The central threat in Project Hail Mary is Astrophage, a microorganism that feeds on the energy output of stars. Now, does something like this actually exist? Or we have not discovered it, but the concept is not as absurd as it sounds. Life on Earth exists in conditions we once thought were impossible. Deep-sea hydrothermal vents with no sunlight, nuclear reactor cooling pools, boiling acidic springs in Yellowstone. Organisms called Extremophiles thrive in all of these environments. Some survive in near-vacuum conditions. Some can withstand radiation doses that would kill a human thousands of times over. The scientific community has a term for this expanding definition of habitability. The Goldilocks zone is getting bigger. Every time we think we have found the boundary of where life can exist, life surprises us. Could something evolve to feed on stellar radiation directly? To use the energy output of a star the way plants use sunlight? Theoretically, the energy is there. Stars pump out unimaginable amounts of electromagnetic radiation, and evolution, given enough time and enough pressure, finds ways to exploit every available energy source. It is not proven, it is not observed, but it is not ruled out either. And that is exactly what great science fiction does. It takes the edge of what is possible and asks what is just beyond it. The Petrova line and solar dimming. In the film, scientists notice an infrared line stretching from the sun to Venus. They call it the Petrova line. It is the trail left by Astrophage as it migrates between its energy sources. This detail is one of the most scientifically grounded in the whole movie. Here is why. We actually do monitor the sun for changes in its energy output. The Solar and Heliospheric Observatory, SOHO, has been watching the sun continuously since 1995. And we know that the sun does vary in brightness. It follows an 11-year solar cycle. During solar maximum, it is slightly brighter. During solar minimum, slightly dimmer. The variation is small, less than 0.1%. But it is real and measurable. Now, could something cause a much larger dimming, something catastrophic? Interestingly, we have actually seen this happen in 2015. A star called Tabbys Star dimmed by up to 22% with no conventional explanation. Sound familiar? We discussed it in our Dyson Sphere video, and nobody has definitively explained it yet. The Petrova line itself, an observable infrared trail in space, mirrors how astronomers actually search for anomalies. We look for patterns, deviations, things that should not be there. The film gets this methodology exactly right. 12 light years from Earth. Grace is sent to the Ceti star system, 12 light years away. Ceti is a real star. It is one of the closest sun-like stars to Earth. It is visible to the naked eye from the southern hemisphere, and astronomers have confirmed it hosts at least 4 planets, 2 of which sit in or near the habitable zone. We have actually pointed radio telescopes at Tau Ceti as part of Ceti searches. It is considered one of the most promising nearby systems for potential life. The film does not invent this. It simply asks, what if the answer to our extinction was already there? The faster-than-light travel the film uses to get Grace there is fictional. We have no propulsion system that comes close. The physics of interstellar travel remain one of the hardest unsolved problems in science. But the destination is real, and choosing it was not an accident. The alien. Without going too deep into spoiler territory, Grace encounters an alien life form called Rocky. What the film does brilliantly, and what the science actually supports, is how they communicate. Rocky and Grace share no common language, no common biology. They did not evolve on the same planet or even in the same star system, but they share something. Physics, mathematics, the same laws of the universe apply everywhere, the same atomic structures, the same chemical reactions, the same gravitational constants. Scientists who think seriously about interstellar communication argue that mathematics is the only truly universal language. It is the one thing any intelligent civilization would have to understand in order to build technology at all. The film uses this premise to build one of the most emotionally satisfying relationships in recent science fiction. And the science behind it is legitimate. If we ever do make contact, the first conversation will probably look something like what happens in this movie. The review. So, is it good? Yes, it is very good. Ryan Gosling carries the film almost entirely on his own for the first hour. And it works. His performance is warm, funny, and genuinely moving in a way that is hard to achieve in a film that is essentially one man talking to himself in space. The practical effects and production design are exceptional. The film was shot on film stock and redigitized, giving it a texture and warmth that most modern sci-fi lacks. The pacing is unusual for a blockbuster. It takes its time, it trusts the audience. It does not talk down to you. When it explains science, it explains it properly. If there is a criticism, the third act resolves some of its tension a little too neatly. The emotional weight of the ending is earned, but the scientific problem at its core is solved with slightly less rigor than the rest of the film demands. And at 2 hours and 36 minutes, some viewers will feel the length. But these are minor complaints against a film that does something extraordinary. It makes you care, genuinely care, about a science teacher, about a rock, about whether one person, armed with nothing but knowledge and stubbornness, can save everything. Project Hail Mary is the kind of film that reminds you why science fiction exists. Not to predict the future, not to scare you, but to ask, what if we are capable of more than we think? Ryland Grace is not a soldier, not a superhero, not a billionaire with a rocket. He is a teacher, and the film argues that curiosity, real, relentless scientific curiosity, might be the most powerful force in the universe. We think that is a pretty good message. So here is my question for you. If you were Ryland Grace completely alone, 12 light years from home, with the fate of Earth on your shoulders, what is the first thing you would do? Drop your answer in the comments. I read every single one. If this blew your mind, subscribe. New videos every week, because there is no shortage of questions like this one. And we are just getting started. Stay curious.